because sometimes in the YouTube studio, I need to click the button to go live as well. No, we are live.
Hooray!
Hooray! Hooray!
It's
This is an
Schrodinger's
automatic.
liveness.
Yes, this is the awkward intro. The automatic live stream is on. Hello, everyone. Good morning, good evening, wherever you are. We are very happy to see you here. My name is Alex Shalaev. I work at Atomic Jar, and this is the Task Continuous live show. It's my incredible pleasure to introduce you this episode. We haven't been active for a few months. It's been a chaotic time, but we're back, and we are back with a bang. Today in our virtual studio, we have an incredible guest, Holly Cummins. Holly, how are you doing?
Yeah, really well.
Where from are you connecting to?
I'm just south of London in the UK.
Nice. Just outside of Europe, as some people could
Don't say that.
put it, but very, very close. Nicely done. Holly is a Java champion, a developer, an author, and currently you are a senior principal software engineer at Red Hat, working on the Quarkus project. Is that right?
That's exactly right. Yeah.
We have the first people in the chat. Hi, Eric. Lovely to see you there. If you are in the chat, drop a message to us and we can make it as interactive as possible. So if you watching this video as a recording and you want to talk to Holly, you can find her on Twitter. She goes by Holly_Cummins. And I think also Mastodon.
Yeah.
Which is the Holly Cummins at Hatchiderm. I don't do Mastodon, but I hope it's a social network that has value. That has value.
Yeah.
Right. So let's. You were an amazing engineer. You have a ton of responsibilities. You were a frequent speaker at conferences. You were an author, so you've written books, right?
Well, yeah, it depends how you define it. I've written one book, and then I've got a couple of chapters in the O'Reilly 97 Things series. So I've got 97 things every cloud engineer should know, and 97 things every what did I say?
Java
Cloud
developer.
and Java. Yeah.
Java
and so then, when I have the book section, I can put those there because I have a chapter in them. But there was 97 chapters. So it was like 1% of the book.
It is a contribution. All contributions are good contributions to open source projects as well. It doesn't necessarily need to be code. So I think this is good. We have Sergey from Atomic Jar here also on the stream. Talking about books, I think very many people say that the first book is an accident. People get tricked into writing that, and then unless somebody has two books, I think they are an accidental writer. Not trying to diminish the amount of work, but just the second book is always so much harder because you know what you're committing into. Right.
Yeah. The first book, you go, yes, I can do this. And then you realize, and then you never write another one.
Yeah, it's very fascinating. I think writing the books is very similar to estimating software projects, where I think the sort of the common knowledge how to do this well is to rely on the sort of the past experience, and preferably not just yours, but other people's past experience. So if you know that implementing a microservice takes like a week, right, or a certain amount of time, it's better to assume that it will take a week for you as well. And then somehow it doesn't work with books. You know that people spend like 2 years to write a book, but when you think about yourself writing a book, you're like, oh, I'm going to do it in like 6 months.
Totally.
And it never works out. Right. So, Holly, you are working on Quarkus. What does it mean? What parts of the Quarkus application framework are you working on? Any particular areas of responsibilities? And
so it's sort of a bit mixed. I'm kind of looking at lots of things, and where it looks fun, I'm kind of shoving my oar in or dipping my toe in. But most of what I'm looking at is the ecosystem around Quarkus. So Quarkus has sort of a core, and then there's some libraries that are really fundamental to how Quarkus works. So for example, CDI, that's fundamental to Quarkus. And then there's sort of an ecosystem of libraries that have integrations with Quarkus, because Quarkus does things a little bit differently, and we do more at build time, and we can compile an application either to work in Java or to work as a natively compiled binary with GraalVM. And getting something to work with GraalVM, if you just sort of take your naive Java application and go, oh, I'm going to make it work with GraalVM, it's a lot of work. So the libraries can do some of that work to make the application work with GraalVM. And so then Quarkus has a set of extensions that make various libraries work as a natively compiled binary. But of course, with any ecosystem, right, the bigger the better. So one of the things that I'm looking at is, just sort of the health of our ecosystem, trying to make sure everybody in the ecosystem is happy, trying to see what are the barriers to entry in our ecosystem. Are there things that we're missing? And that kind of leads me to the Pact aspect, actually, because Pact is something that I'd used as a consultant. And I wanted to, because I was looking at how easy it was to write an extension for Quarkus, I was like, okay, well, I need to try this. And what can I try it on? A lot of the things that you might write a Quarkus extension for have already been done. So it was like, okay, well, what can I do? I know Pact. There isn't a Pact extension. I'll write a Pact extension. So I did it partly as a learning process for myself, but then also, of course, now people are using the extension, which I know because they're raising defects, which is kind of awesome in a kind of terrible way.
Oh, this is an interesting story because Quarkus is a very interesting framework, and as you said, like one of the sort of the marketing around the framework, this supersonic, subatomic slogans that were at the beginning of the Quarkus life, and then a kind of sort of transition into the developer joy messaging about how it feels to develop applications with Quarkus. Those are sort of the consequences of some technical choices that the project did in the very beginning, which is one of them was the augmented build model, where the application framework actually controls the build and can do more at the build time than normal projects, and in a bit more flexible way than an annotation processor would allow you to. So I think that is an incredible technical kind of marvel of how Quarkus came to be. And then through the actual years now, like that system supported all those different additional little benefits, including the extension system. So it's very interesting that you came into the project from an extension. Can you tell us a little bit about like what is Pact?
Yeah, so Pact is a contract testing framework. I think it's probably the most popular contract testing framework. So if you're doing contract testing, odds are you're using Pact. Although there are others as well, so we can talk about some of those others.
Alternatives.
Yeah.
Right. Okay. Absolutely. Right. Yes. So it's a code first tool, I think, and then it helps you with contract tests. We'll get there. Contract tests is one of the big topics of today's stream, and we're gonna get into this. When contract test is something that you normally would use for the system of microservices. How do you like? So how do you describe for an average developer? Imagine I have no idea what contract tests are. Like, what needs to push? What would push me towards exploring what contract tests are and like how to implement them? What are my motivation?
What the pattern that I see a lot is an organization will, they're moving from a monolith to microservices, and they kind of imagined when we move to microservices, because we're distributed, we're automatically decoupled, and we can change each microservice individually, and we can make whatever changes we like, and nothing else will break. And then, of course, when development actually starts, what happens is it turns out that these things are still coupled. And like, just because you made it distributed, you didn't necessarily make it decoupled. And in fact, you can't make it fully decoupled because it's a system. These things have to interact with each other, or else it's not a system. It's just a whole bunch of independent applications. And so when these things interact with each other, always there's like assumptions about how the other microservice that you're calling behaves. And, oh, I think their API looks like this. And it actually, looks like this. Or last week, it looked like this, and then they changed it. And so then you end up with these really kind of brittle systems. They're supposed to be robust, and they're actually really brittle. And then you sort of get into this further spiral where what happens is every time an engineer makes a change, some other microservice somewhere breaks. And so then, of course, the way to, or well, what, often project management and the sort of the governance layer in an organization decides this is terrible. We can't possibly, because the dream of microservices is that you deploy them independently. But if every time you change one, everything else breaks, of course, there's no way that you can deploy them independently. So you have to have a phase where you test them all together to make sure that they work, and you have to deploy them all together. And then at that point, all of a sudden, what you don't have microservices, you have a distributed monolith, because you have all of the things that you were trying to get away from in terms of like, well, we finish and then we go to a big QA cycle and we test them all together and then we deploy them in a batch. And so you're paying the tax for that distributed communications, but you're not really getting the benefits in terms of the business agility or anything like that, because it's too terrifying to change these things if you don't have that lock to put them all together. And
Right.
yeah.
Sorry, I got a slight distraction in the room here. Worry not. So microservices, and you're testing microservices, and contract tests are like a special type of test. Would you somehow align them in the like a common notion of a testing pyramid? Is it a new type of tests? Is it something that you would say just a separate type of tests, or like a kind of tests?
Yeah, like when I think about them in terms of the testing pyramid, I think they fit quite neatly sort of in the middle of the testing pyramid. So like at the top of the testing pyramid, you have your end-to-end tests, which are really expensive to run but give you a lot of confidence. At the bottom of the testing pyramid, you have your unit tests. Those are awesome because they're so cheap to write, but the problem is that they don't necessarily give you that much confidence, right? Like we've all seen the unit tests are green, and yet when you actually deploy the system, it fails. And then contract tests, they're kind of they sort of break the model in the testing pyramid a little bit, because what contract tests give you is they give you almost the confidence of end-to-end tests, right? Like contract tests are really testing that your system works together. But in terms of the effort of running them, the effort's pretty close to the effort of unit tests, right? Like it's all running locally. You don't have to have, you don't have to stand up something else somewhere and then invoke it. You're just running with what your test code thinks it's a mock. But then there's a connection, and that's what the framework does, between what is stood up as a mock for you and what validates that the thing on the other side actually behaves the way you think it does.
Right. So it's that description, what like sounds very similar to me, is when you are doing integration tests, but you are doing them with not within the like sort of a pre-configured staging environment, but locally on your machine, and then you would use either test containers or some other way to set up your service dependencies, sort of databases, message brokers, your Elasticsearch cluster, those things that your application relies on to actually work, right? And then you would call it an integration test, or like it still looks and feels like a unit test, right? It's just a piece of code in your IDE. You can click on the run button, you can debug it locally, everything. So a contract test is a, would you say it's a similar setup, but where your service relies not just on the stock applications like databases or message brokers, but it relies on other services that either you develop or like a completely third-party services?
Yeah, I think so. I have a picture. I don't know if this is actually going to help, but if I
A picture, they
if I
say a
do
picture
that.
is worth 100, 140 words. Okay, it's a pyramid.
Yep. So we have the pyramid, and that is, of course, the test pyramid because it's shaped like a pyramid. And then, yeah, as we were saying, at the top you have the end-to-end test, and then at the bottom you have the unit tests. And I think one of the things that's really interesting now, and this is a bit what you were saying, is like it used to be we had really clear distinctions between these, and that the integration tests would be sort of in the middle, but like it was so expensive to stand up a database that you would never do it unless you were in the integration test phase, or maybe even you'd only do it in the end-to-end test phase. But test containers, I think, is really sort of blurring those lines. So it has a similar kind of thing where it breaks the model a bit, because you have, in terms of cost, it's the cost of a unit test, but in terms of the confidence, you're actually testing against your real database. Um, and so I think what test containers sort of does in terms of the test pyramid is it's kind of smooshes those layers together. And then what contract tests are doing is that they're a layer in the middle, and they have like some really specific characteristics, because what they're validating is the assumptions that each layer, or each service in the microservice, is making about how it's going to be used, and also how it uses things.
Right. Very good. And it's also, but it's a sort of an integration test setup where you run everything locally. So that means you don't need to spin up the whole fleet, a system of microservices. And you can still verify that your code works with other people's code that it relies on, if everyone did their job properly.
Yeah,
Right.
exactly. And I think with both test containers and contract testing, like one thing that they have completely in common is that they're both solving a problem that mocks have. So like when you write a mock, you kind of go, oh yeah, I think because I remember I've mocked so many databases, and it was it was always like wrong, right? Because if I was going to mock a whole database, I could have just written a whole database. So you'd sort of cut a corner, and then you'd make an assumption, and then you'd think your test would kind of work, but
Yeah.
there was a problem. And with contract tests, it's the same. So it means that you you fix that problem that mocks have, where there's no connection between the mock and the actual thing that you're testing, in terms of, is it realistic? I don't know. We'll find out in production.
Right. So could I think about this like as verifying that your like service mocks actually behave how a real service should be? That is excellent. So is it only about sort of REST connections to other microservices, or would I employ contract tests as well when my services talk via like a message broker? Uh,
Yeah, so for Pact in particular, it started for REST, and they've got a couple of things now. So they've got some support for asynchronous messages and that kind of thing. But what they've realized as well is, I think, there's so many new protocols coming out that it's a bit of a hamster wheel for them to try and keep supporting them. So they've made a new framework now, which is plugins. So the idea is that if you have some protocol that there isn't the Pact support for, you can just write a Pact plugin and then it will work. So I think there's a gRPC plugin now and that kind of thing. But it is probably one area where, if you're really not doing much REST at all and you're doing a whole bunch with some of those other protocols, then maybe you want to look at something like Microx, for example, is a new one, and it's got quite a lot of support, not just for REST, but for some of those other protocols.
nice. Nice. I haven't heard of Microx before, so this is already a good learning for me. Thank you. I've heard of Pact. I looked at the website briefly. Can you run me through what are the, in general, or the biggest building blocks or like moving parts that the developer needs to know when they start doing contract tests? If you I don't know if you have a picture about that, or you
And
can just explain, but like the
yeah,
big concepts, right?
yeah, I have a picture, but I think it's probably actually better with if I just explain, because the picture has like a lot on it. So I think the 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 thing the things that are going to be in the system, first of all, is your provider and your consumer. So those are who the contract is between. So the provider is providing the API, the consumer is using it. They need to make sure that they have the same understanding of what's going on. And the way that they establish that shared understanding is with the contract. So the contract in Pact, and I think probably most contract testing frameworks, is a JSON document. And so it will list a bunch of things. So it will, and you can make it as detailed or as simple as you want, really. So it will say, these are the endpoints. This is how I'm going to talk to you on those endpoints. And then you can do, you can get quite specific. And so far, this is like, you could have just done this with OpenAPI. But what Pact gives you on top of that is two things. It gives you sort of examples. So it says, and that helps the mocking. So you would say something like, okay, and when I hit this endpoint, I expect to get back, I'll show a demo in a little bit so I can use the examples from that. I would expect to get back a skein of wool. So I expect to have wool, and I expect it to be color white, and I expect it to be, length 200 meters or whatever. So that means that you've actually got something concrete to use as your mock. But then you can also do more interesting things as well. That starts to get much more towards a functional test. So like with OpenAPI, you say, okay, I expect you to have this endpoint, and you can return me a 200 or you can return me a 400. But it doesn't really say, like, under what circumstances are you going to give me 200? Under what circumstances are you going to give me like a 400? And if I pass you in a response or if I pass you in some query that I think is totally valid, actually, if I ask you for black wool, is that going to give me a 404 or is that going to give me a 200? As a consumer, I'll write code to handle both, but I really kind of care if what to me is the main use case is for you going down the error path every single time.
Right. So the contracts go beyond OpenAPI, sort of documenting the endpoints. Would it be fair to compare it to the sort of schema validation, but like with examples? Because when the communication goes via, like, again, a broker, for example, very often you would have like a schema registry, and everyone conforms to the particular schema, so there could be no misunderstanding about the shape of the message, or I don't know, there could be no typos in JSONs in the keys, right? Like, could be in values, of course, but not in the keys. Does contract tests add a layer of something on top of this?
Yeah, and this is sort of getting into a bit of a religious debate among the contract testing community, actually, is that there's two sort of broad categories of contract testing. One is consumer-driven contract testing, and one is provider-driven contract testing. And they both, like, people get really excited about which one is right and wrong, but they're for different use cases. So, like, for example, if I'm Netflix and I have an API, there is no way that I'm going to go to every consumer of my API and say, hey, could you just give me some contracts and I'll do what's in your contract, right? Because I don't even know who all of them are. There's so many. So instead, what I'd have to do is I'd have to publish, I'd say, and I probably would use OpenAPI as the format. And I would say, okay, here's what my endpoint does. Maybe, we can use that to generate a mock for you. Maybe I'll give you examples. But ultimately, this is what it does. But another way of doing it is consumer driven. And that works much better if there's good communication between the provider and the consumer. So that's, for example, like if you're a team and you're developing a system, consumer driven can be really nice. So it's a bit like TDD, but between services instead of just within a single code base. So as the consumer, I say, I need a thing that gives me wool. And so this is what I want for my wool. I need it to have this field. I need it to have this field. And then the provider will go and they'll write to the test. So it's exactly like TDD. And it means that, I think often when we're writing a service, we don't really know how it's going to be used. And we kind of imagine oh yeah, everybody's going to use this. But maybe no one's using it. So why are we wasting our time writing something that's not going to get used? Or the other thing that can sometimes happen, right, is we're really enthusiastic and we go, right, I'm going to have these 62 endpoints. And then a year later, we're like still maintaining these 62 endpoints. And we'd really kind of like to reduce them because we have a feeling that the endpoint that's totally obscure, no one's using, but we don't know. Whereas if we have consumer-driven contract tests, that means that we can get rid of things, because if we don't have a contract for it, it's not being used. So then, so that can be sort of quite nice, both for the sort of the Yagni model of development of like, you ain't going to need it, but then also to understand the impact of deprecation.
I'm sorry, you said the Yagni, and I heard the agony, and I was like, yes, development microservices is an agony model of development.
Yeah, totally. Yeah, we encourage the agony model of development.
Agony, yes, it's a struggle. It's a struggle. You look at your test; they're always broken, right? You mentioned the consumer-driven contracts, the producer-driven contracts. We have Tom Cools in the chat declaring the that he's liking consumer-driven contracts more. Do you have a preference? Does it is it mostly based on the whether you are doing like a public API versus internal systems, or like if you know what you're doing, you can do both?
So like for me, I mean, it's really interesting actually, because for me, consumer driven, because I love TDD, and consumer driven feels really aligned to TDD. But I have seen the Microx, which I mentioned earlier, they do provider driven contract testing, and they wrote a blog comparing the two. And I'm, if I recall correctly, one of the things that they said in there is like, oh, provider driven testing, it's so much like TDD. So again, I think, we all kind of match our mental models to match our preference. So for me, I have a preference for consumer driven, but if I was writing a public API, I would completely do provider driven, because that's if I was writing a public API and I didn't have a relationship with the people using it, if it was kind of like a broadcast API, then provider is the way to go.
Right, of
The
course,
other,
because like contract tests in general, I feel from what you're saying, a lot about communication between the teams and sharing this desire not to break each other while you're evolving, and rather than like technical excellence, maybe.
Completely. And I think that's one thing that is sort of a barrier to some teams when they try and adopt contract testing is exactly that communication, and that like trying to understand, okay, well, if a break happens, who has responsibility and how do we sort it out? Because one of the things that happens with the consumer-driven contract testing is the consumer will define the contract, they'll use it as a mock, and they share that contract to the provider. And so there's a couple of mechanisms, like either they'll check it into the provider CI, or you can use a broker to kind of, we upload to the broker and then they download from the broker. Right. But either way, it should be validated in the CI. And so that means that there has to be a trust, right? Because if as a consumer, I go, hey, I've decided you're going to have the new endpoint that returns me Bitcoin, then, that gets checked into the provider CI. And funnily enough, they don't have that capability. And so their CI breaks. And so then it's like, okay, well, how do we sort this out? Should I have, even, that was an extreme example, but maybe it was just a more reasonable thing where I thought you were going to have this API finished and you didn't. So I made the contract and we didn't coordinate the timing, and now your build's broken. So like, how do we manage that? And if you get that kind of antagonistic relationship between the teams where they're always like, we would have made our deadline except team X blocked us, then the contracts become another tool, that you can sort of use to beat each other up with.
Exactly. So thank you for the answer. We have more comments in the chat about the consumer-driven tests, and then requiring some domain knowledge, and how Pact is not a proper replacement for schemas. Please, Oha, if you could elaborate about that, I think it would be interesting to see the arguments and your line of thinking. That I think at this point, I would love if you have a sort of a sample application.
I do.
I think I'm ready to see the code, because now I know that there has to be a consumer, a producer, a contract. If you use Pact for contract-based tests, you need Pact and potentially a broker to facilitate the contracts. And then you have two types of tests: one's on the producer side, one on the consumer side, and then this whole system, which got so much more complicated than just 2 microservices. Is supposed to work in a particular order. So I think maybe looking at the code will clarify some points for me.
Cool. Yeah, let's see. So
And it's all obviously going to use Quarkus, right?
Yep.
Does it work with Kotlin?
Does it work with Kotlin?
Yes, just kidding.
Oh.
No, it's just.
It's actually, my first response was I have no idea, and then my second response was no, I absolutely know, because so Pact is polyglot and it has bindings for like all sorts of languages, and I think it originally came from Ruby. But there's a JVM binding, and the JVM binding is written in Kotlin, which is one of the things when I was integrating it to Quarkus that caused a little bit of I had to do a little bit of work. So like in Quarkus, you have continuous testing, and so every time you change the code, it just it uses code coverage to figure out what tests affect what code, and then it just reruns those tests. But the class loading in Kotlin was like a little bit different, and it interfered with the continuous testing, so I had to fix that and that kind of thing. But hopefully, am I sharing my screen now?
Not yet.
No, not yet. No. Okay, I am sharing my screen.
Now I can see it. Now I can see
Cool.
it.
So what I have, the domain model here, it was sort of, yeah, it was a good question about the domain model. Let me go full screen. So the domain model here is just the supply chain for sweaters. So I can go to the sweater shop, which is a front end, and I can order and nothing happens. And the reason that nothing has happened is because I have a cool little thing that I just want to show you before I do. Where is it?
Because there is no backend, right?
There
Am
is
I
no
right?
backend, exactly. So the application itself doesn't actually use a backend, but I've got a little sort of, for the demo, I've got a little thing that tracks the interactions, and that uses a backend. And so I have my little backend service, and you can see that I have configured it to point to Mongo. So I've got it using, I've in the code itself, I'm injecting a reactive Mongo client that I use for some things, and then I have Quarkus has a programming model called Panache, which is an extension of Hibernate to remove a whole bunch of boilerplate. So here I have a component, as in a component of the application, which is just an entity. So it should just, via the magic of Hibernate, go in and out of my database. But the one thing that is missing is if I do not have in any way a container. And I've got a container configured, but I'm not actually running it, so nothing works. So now, if instead of having that application, that container configured, I just don't configure anything. So now I'm telling Quarkus, I would like to use Mongo. I have Mongo dependencies in my POM. I'm using Mongo libraries here. I cannot be bothered to set up Mongo because that seems like hard work. Then what we should see is if I go back and I order a sweater, I have a backend.
Oh.
So what was happening, so this is the test containers integration. So you can see it's red, but that's a different thing. So you can see if I go back and I look and see what containers I have running, I have the test container, I have test containers running to manage my containers. And then I
the
have
resource
Mongo.
reaper and Mongo.
Yeah. And Mongo.
4.4. What isn't like Mongo 8 or something the current? Just kidding. Like whichever database works for you, it is okay. It is okay.
Yeah, that's a good question, because Quarkus are usually pretty good at like staying up to date on the latest. So I don't know.
It is fine. It's the for uninitiated, this feature is called Quarkus Dev Services, and it provides an integration between Quarkus and test containers, and Quarkus uses test containers API to spin up the service dependencies for you for some predefined technologies like your relational databases, NoSQL databases, message brokers, and so on, without any configuration or effort from the application developer. So it's a wonderful synergy there. Okay, so like now your application works, right? And you can order sweaters.
Sort of. Yeah, so normally how you might do it is you might have, like, for example, a profile for production where you actually do connect to a real MongoDB, not one that was spun up by test containers, and then you'd have for development, you'd use test containers. So we use test containers both for mocking for tests, but then also just for general development. And I have to say, I have, since I've been on the Quarkus team, I've hardly ever actually spun up a database, because if I don't configure it, it just works, which is kind of how everything should be, really. But going back to the application, you can see that what's happening is my BFF is the cold person, and so an order goes in, but it comes back with a connection refused. And that's because this is a microservices application, and so far I have one microservice, which is the cold person. So if I go back to my knitter, and if I do Quarkus Dev,
so it's another microservice in our system to actually simulate a producer and the consumer, right? Because we don't want our producer to be like an HTML page, like a website. We want an actual like microservice that is an application that is testable.
Yeah, exactly. And so, what is it with demos? Okay, I have no idea why I had to reload that page, but you can see now I've got two services and an interaction between them, and the order gets passed along. But it still doesn't work because my knitter doesn't have any wool. So to have the wool, we need another service, which is the farmer.
Okay.
Oh, no, hang on. No, this is the knitter. I've just killed the knitter. This is the farmer.
And so this is now like a second producer. So the one in the middle will be both a producer for one end and a consumer for another. Okay.
Yeah. And if your head hurts, you're not alone. I really sort of, in doing the demo, I struggled a bit to come up with.
I think this is a very typical use case, right? Like our services are very often both producers and consumers of API, and this is natural.
Yep, completely. And so now if I do this, then you can see it actually works. And what this shows you, I think, is that microservices are annoying, right? Like this is such a trivial application, and just in order to run it, I've had to spin up 3 services. And I've also, because of the demos, I think my database is clearing itself on every request, which I have no idea why that's happening, but we'll ignore that. So I have a functioning application now, and I can see what's going on. But if I go back to my farmer, then I've got this record here, which is what's getting serialized by Jackson and passed along the line. And you can see I spelt color with a U because I live in Britain. But we do have some American colleagues, and particularly the timing of this, there might be that, it's a US-friendly time, so they may be more comfortable spelling it like that. So if I do that refactoring, then
I'm a non-native speaker. I could spell anything in any way. And we also need to remember that even the HTTP referrer is still like 50 years later, still has a typo in it. So
yeah. And so you can see I've got tests, and the tests are all, Quarkus has just rerun the tests because it saw something changed. My tests are passing, so it's all good. So now if I go back to my sweater and I order another white sweater, boom.
When you said the tests are passing, like those were normal like unit tests that the like serialization of things works, and then maybe going into the database works, like all those tests, not the contract tests yet.
Exactly, yeah. So I don't have the contract tests yet. And what you can see is things sort of seem to work, but like when the order went in, it went in with a U, and then it came back as color white, which meant that when it got to the knitter, which was expecting color with a U, it passed a null down, and nothing actually broke. But in terms of what got passed back, we have no idea what the color was. And this is the kind of thing that actually, like, mocks completely would not catch this, because if the knitter had a mock of the farmer,
Yeah,
it would,
if you implement a double, right, for the service, which is your mock, then and you implement the test that relies on that double, chances are there are some copy paste happening. Chances are that
yeah.
the implementations will be very similar, and chances are that they are not actually validating the behavior that you want to.
Yeah. And so I can show you what a contract test would look like. So I've got, I'm now on the knitter, which is the consumer, and I have this test, which is just a normal test. So you can see in a normal test, I inject a mock and then I make some assertions. And so instead, what I can do is I can make a new test. I'm going to call it the sweater resource contract test. And it's actually going to be almost exactly the same as the sweater resource test. So let me just paste that in and then adjust the name back. The one difference is that instead of doing just an inject mock and letting Mockito define what's in my mock, I'm instead going to use the packed DSL. And I'm also going to add the packed extension. So if I do Quarkus Ext add packed consumer, then that has installed the extension. And now in here, once I refresh my POM, then, so what you can see is this is quite similar to defining the mock, but I'm actually having to be explicit about it. So I'm saying there's a packed DSL. So I'm saying I expect my wool order to have a color, which is a string, and an order number. And then I expect it to give me back this and that kind of thing. And so then the one other little bit that I need to do is add another header to say I'm using packed. And so then if I run this after importing a few more things, whoops, yeah, let's get rid of that too.
Right. So let me reiterate. We removed the mocks.
Yeah.
We added the Quarkus packed consumer extension.
Yeah.
To help us integrate with packed, and then we extended our test to run with the packed consumer test extension.
Yeah.
And then we define, using the packed DSL, we define what response we would like to get when we query something.
Exactly. Yeah. Yeah. I like doing demos with you. You summarize as I go along. And so.
Thank you.
Yeah. So this here, it's exactly like defining the mock before. And one thing that some people have noticed is that this is just sort of vanilla packed, and it's a bit verbose compared to what it was in the other test. And so I'm hoping that there's a technical reason about JUnit class loading why we can't do it yet, but I'm hoping that we'll be able to get rid of a lot of this boilerplate with the Quarkus packed integration. But the exciting thing is that we should have, now that we've run these,
I see red in the console. There's something that can be
Yeah.
found. Is it a
So
problem or is it
no. So this is this is something. It's a you know how like they say disinformation spreads faster than information and that kind of thing. You can see that when it ran the tests twice, and the first time there was an error because I hadn't imported stuff, and then the second time it passed. So whoops. Now it's scrolling like crazy. Wow,
it,
now
it
it's really scrolling like crazy.
it's fine. It looked like a warning anyhow. Developers ignore
Yeah.
warnings until it breaks. It's all
So
good.
what it was showing was there was a line at the bottom saying all tests are passing, but
Yeah.
before that it failed. So that's why it's showing that. So, but it is flashing as well. So what I'm just going to do is we should have a folder in Target called Pacts. And you can see we completely do not because live demos.
Right. So
So let's
while you're
run this. Yeah.
while you're running this, let me give you my understanding what's happening, and you're going to tell me whether this is correct or not. We wrote our test. We used pack.dsl to define what we expect from the producer when we query it with something, and then we run the test, and that test passes. That test passes, which means that our consumer sort of works when the producer is sensible. And because this is our packed implementation, of course it will be sensible, right? So this is not unlike a mock, but it also produces this JSON file that sort of describes our expectations to the producer in a contract form, right? So we
Yeah, exactly. It's like a mock with benefits. So
okay.
from my code, it was just a mock, but then but then we get this JSON, which is, it's a bit like a schema in terms of saying I expect this and I expect that, but a schema mixed with examples. And so then that means that I can publish that. And so, like I said, normally you'd publish it into a CI, or you'd use a broker or something like that. But this is just like a little local demo. So I'm just going to do it by a manual copy on the file system. And then I can go over here to my farmer. And then I'm going to need, so again, for my wool resource, I've got a test, but I'm going to make a new test that's using packed. Call it contract test. And then what I'm going to have in here, it's pretty quick, but I'm going to use the template for it. And I've forgotten what I've called my template because live demos.
It is absolutely fine. It's very many developers nowadays dabble in copy pasting production code from various sources. Before it was Stack Overflow almost exclusively. Now there are various AI augmented services to copy code from, which we do not support officially. So it's fine. Like for the presentations, this is absolutely fine, right? So now you copied the contract. So now the contract is shared between the consumer, where we generated that, and the producer.
Yeah,
and now
exactly.
now we are on the producer side, and we're going to use that contract to verify that our service actually implements the contract that the clients expect it to.
Yeah. So I've got my contract here, and you can see there's not much here. I'm telling it what port Quarkus is listening on, because it does go in. It sort of goes in via the outside. It goes in via the front door. So it listens on the port, or it talks to it on the port. I have to tell packed. So this is me telling my test what port it is. And then this is my test telling packed what the port is. And then this is just a JUnit construct to say test template. And I'm going to extend with packed. And then I just say context verify interaction. And if I run these, then we should find.
Ooh, This is so neat. Oh, it's
that
I th-
it failed.
oh, so we just put the contracts and we create the tests, which is literally this, because all we need to do, we need to say like spin up our application, spin up all the infrastructure adjacent to that, like the packed infrastructure, whether that is a broker or anything, and then tell our test and packed how to go into our application and where the contracts are. And based on the contracts, it can generate the test for us to go into packed and go into the actual producer, trigger the responses, send the actual queries that we need, and then verify that the responses conform to the thing, to the contract.
Yeah, exactly. So like both sides are getting something out of it. So for the consumer, it's a mock, and for the provider, it's a functional test. And so you can see here it's failing because I messed it up. So now if I go back and I undo my refactor, and if I put in color and do my refactor, and then I should be using continuous testing actually. We should find that my tests are passing. And yeah, again, we can sort of see if we want to double check, we can run it in the IDE UI too.
This is brilliant.
That's really
and
cool,
then
isn't it?
if I would have multiple consumers, they all can write their all dedicated contracts, well, their mocks that they expect to work with, and then those would produce the contracts. All the contracts will like get into the producer, so I would have a set of expectations from everyone who's actually trying to use my service, and then like within those boundaries, I can change whatever I want without breaking anyone.
Exactly. So it's really quite powerful. And so far, like this, you could have done this with OpenAPI because we're just like a schema would have caught that color thing. But there's I won't show like the full thing, but I'll just show a quick example of where a kind of problem that I think is realistic that OpenAPI wouldn't catch, which is if I go back to my application, so I can order a white sweater. And whoops, oh, I've stopped something, haven't I? I stopped my knitter. So normally with dev mode, like the point with dev mode is that you don't have to stop and start the application, you just keep it running, but I stopped it. So if I, right, so now I've got, and I get a white sweater, I can order a gray sweater, and I get a gray sweater, I can order a black sweater, and I get a black sweater, and this is all working really well. And then I can order a pink sweater, and something's happened because I got back a white sweater. And again, it was because the request went into the farmer for pink, and the farmer sent back white. Because you can see, if you look at, like, this is the sort of subtle problem that might happen in architecture, where the farmer, if I ask for a black sheep, the farmer, or if I ask for black wool, the farmer just goes and finds a black sheep. If I ask for white wool, it goes and finds a white sheep. If I ask for pink wool, what's it going to do? There is no such thing as a pink sheep. So there probably should be in this architecture, there should be a dyeing service, but everybody thinks it's somebody else's problem, right? So as far as the knitter is concerned, it just says, give me wool of this color. And as far as the farmer is concerned, it's a farmer, it's not a dyer. And so if you get a request for pink and it can't give it, there's no pink sheep, it just gives you back a white sheep, and it thinks it's done a good job. And if we'd said instead, like if instead of having a fallback to a white sheep, if we'd returned to 404, there still would have been a problem, right? Because from the perspective of the person doing the order, they wanted a pink sweater. Yeah. And if we propagated a 404 along, they didn't get a pink sweater. And so with schema validation, all you could do is say, there's these fields. But in the knitter, what I did is in my contract test, I gave an example of white, but I said what I get back can be any any string, and I could revise this test to be a stronger test and say, if I ask for white, I get white back. If I ask for pink, I get pink back. And then that means, that's something that you couldn't have in Open API. And then it means that I would get the test failure, and then I could have that conversation about the business process to say, okay, we need a dying service.
Right. Yes, because the contracts are like a set of examples that would support the particular integration between services. It doesn't necessarily cover all the cases, but it does give you the examples. So if something doesn't support these, then definitely it doesn't support all use cases in the future. Yeah. And Kevin, I am thinking about pink sheep. I think it's a very philosophical idea.
Oh, I have a slide for that, actually. Let me just find my...
Photoshopped a
No,
sheep.
it's not Photoshop. That's the best thing about it. Because again, this is the sort of misunderstanding that can happen. Because you might say, oh, well, this is a totally ridiculous demo because everybody knows there's no such thing as pink sheep.
If you're gonna show, we're gonna get canceled for animal cruelty.
I think
no, it's fine. It's gonna be fine.
Yeah.
It's gonna be fine.
Yeah.
No, this is brilliant. I love this. I love your demo very, very much. Oh, I see it. Yes.
Oh, hang on. Oh, yeah. There we go.
Yes, perfect.
So, yeah, I shared the wrong thing. So this is the Latitude Festival where they do actually dye the pink sheep.
Okay. So. This is perfect. I know people who would absolutely love this picture specifically. Thank you. No, it was very, very good. It felt very fluent, even with the 3 microservices, which is not the simplest example. I think the standard would be just a producer and a consumer. But I think I recognize where the parts go. And if I would try to put this into action on my projects, I think I have the enough pointers how to enter the world of contract tests. So thank you so much. If you have any questions in the chat, now is the good time to ask. I have one sort of a little bit less pointed question from Tom, who said that he was building a Quarkus application which required HPS and WSS connection, and he didn't set up any keys or trust stores, but everything worked, and whether Quarkus sets that up automatically. I'm not sure if you have an answer to that. From the top of your head.
I don't know for sure. I mean, in general, the Quarkus philosophy is do as much as you can at build time, get rid of the boilerplate, and try and do it automatically. So it probably did, but I don't know the details.
I think it absolutely did. If you expected something not to work and it worked, it means that somebody else did the job for you, Tom. Well, I mean, the hard parts of the job, not the actual all the job. We will need to figure out and look at the documentations about how that works. Right. Thank you so much, Holly. We are at the hour, so our time is at close. Just to summarize, we talked a little bit about contract tests, about how to implement them, what are the problems that will push developers and projects to use contract tests, namely they want to build functional systems of microservices and not break it every time somebody changes and redeploys their service, which is outrageous.
When you put it like that, it's fairly desirable, isn't it?
Yeah. Like, why wouldn't you? What wouldn't you want this? And we talked about pink sheep, and you showed us a wonderful demo of 3 Quarkus applications talking to each other, and we implemented a bug in the communication, breaking the schema, and then I say we as if I was a integral part of the process, but you implemented.
Hey, you gave very good commentary. You were totally integral.
We implemented the tests on the consumer side. We generated the contracts JSON files for those tests, and then we used the same files to verify the producer behavior in a functional in a functional test, leading to discovering where the problem was, fixing that, and verifying that everything is green after the fact as well. So I think that's quite a lot of ground to cover. And thank you very much, Holly. If you are watching on YouTube, please follow Holly, ask her any questions, say thank you for the insightful session. I loved this episode. Thank you so much for joining us, and see you somewhere at the conference, and see everyone online maybe next week on the next episode of Desk and Trains Live. Thank you.
Thanks, everybody. Thanks, Oleg.
Okay, I'm gonna click the stop button.
We can stop in the